This example is a really good one for showing how much better a probability tree is than an ordinary tree diagram. As you can see here, it's talking about a fruit bowl and it contains 3 oranges and 4 apples. With a normal tree diagram, we would need to have 7 branches, starting with 7 branches, and for selection 1, and on 3 of those branches would have orange on them and 4 would have apple. Now, as you're going to see, because we can separate this into just 2 results, one being an orange and the other being an apple, we're going to be able to reduce the size of the tree significantly. However, those 2 branches will not be worth the same because there are more apples. So orange and apple, and by the way, this is choosing 2 pieces of fruit, first choice, and over here we'll have second choice. So there are our headings, what the first choice was, what the second choice was. Now, like I said, to choose an orange with only 3 pieces of fruit being an orange, then it's probably the branches are not equal and it has a probability of 3 in 7, and an apple will have probability 4 in 7. The second choice, after an orange has been chosen, is still an orange or an apple. There are still oranges left. However, now there are only 2 oranges left and there are only 6 pieces of fruit left. So this is where the probability for the second choice will depend on a prior selection. So this is again something you might need to note in your summary and key points, that you're going to see that not all the probabilities on all branches are the same. And you've got to really be thinking about the situation and varying the number as required. So hopefully you can see that the probability now of the second piece of fruit also being an orange would be 2 in 6. But remember, I've always said you should reduce that to 1 in 3. Then we know that there are still 4 apples. After an orange has been taken, still 4 apples, and that would normally be 4 in 6, which we know is 2 in 3. And we can see that the test for the probabilities adding to 1 is actually evident here. If the first, sorry about that disruption with the phone. If the first piece of fruit was an apple, then we could certainly, our second piece of fruit could be still an orange and an apple. There are sufficient. And the probability of choosing an orange, there are still all the oranges there, which is 3. There are only 6 pieces of fruit now because there was an apple taken. So that's a half. Now we know that because these have to add to give 1, then the probability of an apple should also be a half. How do we get that? Well, there were originally 4 apples, 1's been taken out, that leaves us 3, and there are now only 6 pieces of fruit, and 3 and 6 is a half. So again, we see the probabilities adding to give 1. So what are our possible outcomes? Remember, this is the most important piece of information that you can actually write down. Our possible outcomes are orange followed by an orange followed by an apple followed by an orange, and an apple followed by an apple. And the way that we actually get the probability is to multiply our probabilities across the branch. So A is asking for the probability of 2 oranges. So we're going to follow along this branch, orange, multiplying the probabilities that we have. So 3 on 7 times 1 on 3, which gives us 1 in 7. And B the probability of an orange and an apple. An orange and an apple occurs here along this branch, and this would also result in an orange and an apple. When we've got two branches, we need to add those two probabilities. So we actually want the probability of an orange and an apple plus the probability of the apple and the orange. Please don't forget this. You need to add the probabilities if you need more than one branch. You're adding the branch probabilities. So that's equal to, let's get rid of that. Not very nice. What is the probability of an orange and an apple? An orange is 3 in 7, followed then by an apple, which is 2 in 3. Add. The probability first of an apple was 4 in 7, followed by an orange, which is a half. So that becomes, those 3's cancel out. We've got 2 in 7, and 2 into 4 is 2, which is 2 in 7. So the probability of getting an apple and an orange is 4 in 7.